All right, sounds great. Hey, everybody. Hope you all doing good. Um, I'm gonna do a little presentation on how to make some plots with R, give you some basics. If you have any questions as I'm going along, I'm gonna try to make this kind of interactive. And if you have like an idea of, hey, what if I want to do this or that with the graph, let me know and I'll try to do it on the fly. Um, and I'll show you how at least my coding, I did not learn this formally. I kind of taught myself. So my coding experience oftentimes is, oh, I want to do this. Let me Google if anybody has done it before and see how they've done it and then adapt it to my own needs. So I'm going to do just like a quick little slideshow on some basic principles and how ggplot, which is the package that I'm using in R, understands graphs and the grammar of graphic behind ggplot. And then I will go and just get into my R and start making some graphs. And then you can kind of see how it goes. I've never live coded for anybody before, so please bear with me if it's a little bit of a messy process, but we'll see how it goes. So let me go ahead and get started on my my little intro presentation here first. So just so you know, I tried a few things that were new to myself too. The slides were also made in R, so just to kind of my first time trying this. So just to show you how versatile this is, I'm not paid by them to do this, but just wanted to kind of let y'all know this is actually really a cool tool. So I'll go over a few basic principles first. Basically, being accurate, being clear, showing as much data as you can without cluttering up the graph. Basically showing the science, not trying to sell an idea. Ordering data so that the graphs are a little bit easier to read. And then when we get to colors, choosing those in a way that they actually work for everybody. So on my first one, being accurate and clear, everybody's probably heard of this idea that pie charts or pie graphs really aren't the way to go, right? Everybody loves their pie charts, apparently, but the idea here is that we have a choice on how we want to encode and show data graphically, right? If we have percentages of users or people using different browsers, right? We can encode that in different ways graphically. And a lot of times people will use this pie chart and they might try to show with this pie chart how that has changed over time. Right? If you look at this, if you don't have any numbers, any percentages written onto the pie chart itself, it's very difficult for us to figure out by the area and the angle of these lines how these percentages have changed or what these percentages even are, right? This is maybe about a quarter or something like that. It's probably a little bit more than a quarter, but it's hard to see. So it really doesn't tell us much without putting the percentages on here, right? And then if we put the percentages on here and write them on there, then it can get a little cluttered because we've got this little sliver right here for the Opera browser that we'd probably have to put a line and put it off to the side. And then it becomes harder to read. And if we're putting percentages, we might as well just put a table there, right? Whereas if we use the bar chart instead, right, then we have our percentage right here on the y-axis, and we can pretty easily see what these percentages are and how they change over time. Much easier than in a pie chart. Makes sense, right? People have then started using donut charts where the middle is kind of cut out, but then we're taking actually away the idea of the angle, and now we only have the area comparing to each other. Doesn't really help much. So really, the basic bar chart for this is probably the best way to do it, right? And so the overarching idea that I'm trying to get at here is make sure you pick an accurate and clear way of encoding this graphically, right? So people will use areas or radius of a circle to show different sizes in comparison to each other. There's some issues with that. So really kind of focus on pick something that's accurate, pick something that's clear. Next principle, show me the data, right? So this one right here is everybody probably is used to these from publications. They're called dynamite plots because we've got the stick of the dynamite right here, right, with our whiskers right here showing the standard deviation or standard error or something like that. But it really hides a lot of information, right? And there is, if you Google this, say no to dynamite plots, there are a lot of blog posts and also scientific papers that argue to not use these, even though that's probably what a lot of people are used to seeing from scientific publications, right? Is comparing some kind of groups or something like that with their means and then a standard deviation or a standard error, which is problematic. But we're not going to get into the details there. Rather, what we could do is show a box plot like this and then overlay the individual data. And one of the plots we're going to create today, if we get to it, is one of these box plots, right? And so if you see this, right, this immediately that has the same information, has the mean or the median right here, but we can now actually see the variance a lot better than with the standard deviation or the standard error because we have the individual data points and we have the distribution of those data points and we have all the information encoded in a box plot plus the individual data. The interesting thing is, if you look at this is just a copy of this one right here, but these two box plots right here would have actually both created this same dynamite plot, right? So you can see how these data distributions are clearly different from the ones on the left right here. But if you'd only shown it in a dynamite plot, you would have gotten the same dynamite plot from it, right? So this is the importance of showing the data, right? Yes, okay, we're comparing means and standard deviations right here, but this gives us a lot more information of how the data are distributed, right? Any questions on that? Okay, so science, not sales. This one is a very extreme example, right? But knowing when to include zero in your y-axis, right? A lot of times you say, hey, if anytime you have a column plot or a bar chart or something like that, you want to include zero because the length of that bar or that column or the height in this case, if we have vertical columns, will tell us something about the data. And if we do it something like this over here, right, where they're not showing a zero and they're really exaggerating the comparison of votes received by Maduro versus Capriles right here, right, at 50.66, making that look much larger than the 49.07 right here, like basically a non-existent bar versus a very large bar. This is basically selling that this was a much larger victory than it actually was in truth, right? In reality, right? Whereas if you showed a zero, obviously right now we can see that was a pretty small margin of victory right here, you know, like a 1.6% approximately difference right here. That is exaggerated right over here, and this shows kind of the true difference. Now you probably don't see it in this extreme of a fashion in scientific articles, but you might see still where the zero is cut off, and you're starting at, you have pretty large differences in your bars when if you included the zero, that would not be the case, right? I'm sure everybody's seen this before, so you know that's an important one. And this is not just limited to showing the zero on bar graphs, right? The overarching idea here is be true to what you're showing. Don't try to sell a point with your data visualization. Specifically if it's for scientific purposes, right? Ordering, right? So these are from an Introduction to Data Science course that's actually freely available on edX. I've pulled some of these principles and some of the charts from there. And it has all the data, all the code to produce these charts. if you look here on the left, right, this is in alphabetical, and for some reason in reverse alphabetical order, it's murder rate by US states, right? And this is, okay, we can see District of Columbia poking out here with a very high murder rate, right? But all the other comparisons are very difficult to make between states, because they're very far apart with very similar rates. So can we easily see if this one is larger than this one right here, right? Like Nevada versus Illinois, for example, we probably can't. But then if we order it by the rate, now we clearly can see the rate is decreasing, and we can see Nevada right here having a little bit larger rate than Illinois, for example, right? And in R, this is one line of code to reorder the state by the murder rate, right? So it's an easy thing to do, and it makes it much more legible and much more easily to understand. Same idea right here. This is um, dollars per day. I want to say this is GDP in dollars per day, for different regions of the world, right? And then within the regions, the individual data points are countries, right? If we order it alphabetically, it's very difficult to compare different countries to each other or regions to each other. Whereas on the right here, we've got it ordered by the median of the group, and now we can see the comparisons pretty easily, right? Rather than alphabetically. Any questions on that? Pretty straightforward. This one was something that I had never thought about before I started using R, to be honest, is thinking about colorblind friendly colors, right? So this is something I had not considered, but a lot of times, it's not a large portion of the population, but there are enough people to where this might matter, to where if we have certain colors that colorblind people with different types of colorblindness might not be able to distinguish, right? So there are certain packages in R that specifically provide colorblind friendly palettes, and that also let you analyze your graphs and then show what they look like for different types of color blindness, right? So it's actually pretty nice to do, pretty easy thing to do in R, and it's something to keep in mind. If you want to choose colors that have been kind of pre-selected, you can use what's called this color brewer package that's showing here on the left. And the nice thing they have is they have the colors arranged by, if you want to show something that's like a sequential change in color, right? You've probably all seen graphs that show continuous data encoded by color, where it becomes a darker color or maybe a different color as a value increases in number, right? And so they have sequential palettes. And so if you don't know what all of these are, you can just tell hey, use one of these sequential palettes because we have continuous data that change in a sequential fashion, and it will pick one for you, right? Or maybe you have categorical data, and Color Brewer calls this qualitative. So you can just tell hey, use a qualitative palette, and it will pick one for you. Or if you want to pick a specific one, learn the names, go to Color Brewer help file, and look at what they look like, and then tell hey, I've got categorical data, so use set 1 or set 2 or dark 2. I like this dark 2 a lot. It's also colorblind friendly. You can tell R, give me all the colorblind friendly Color Brewer palettes, right? Or then these are differential data, right? Where you've got data that are kind of going one way versus the other way. Maybe one of these palettes is the best one. So any questions on that? Okay. All right. And I will show you some of this as we're going through the different graphs. So just briefly, I wanted to show you all the idea of this ggplot, and that's part of why the package is called ggplot, right? Because it's based on this grammar of graphics that was first proposed by Wilkinson. There's a whole book on this, and the book does not go over, hey, for displaying a certain type of data, use this type of graph. No, it goes over if we want to plot anything, what's the best way of arranging or coming up with a grammar of code or a structure of code and functions to graph anything. And that's the nice thing about ggplot. I don't know why it's called ggplot2, to be honest. And I know we have some R users here. I don't know where the 2 comes from. If somebody knows, let me know. But the GG is based on this idea of the grammar of graphics. There's some other software that uses the same idea, Tableau. I don't know if anybody uses Tableau, but it's also, excuse me, based on a grammar of graphics. ggplot does not follow Wilkinson's exactly, but it kind of comes up with its own, but it's based on a grammar. And the nice thing is you can graph anything from scatter plots, bar graphs, all the way to maps, spatial data, anything, and you use the same commands. You use the same kind of layers, and I'll show you those layers briefly here in the presentation, and then we'll kind of get into the coding, and I'll show you what it looks like in R using those layers. Excuse me. Okay. So the grammar of ggplot is based on these 8, make sure it's 8, yep. These 8 kind of grammatical features. So you have your data, you have then the mapping of the data to a graphical representation. ggplot performs some statistical functions for you. You can then you can provide scales or change scales. You can provide or change geometries. You can have facets, so multiple panels in a plot. You can adjust the coordinates, and you can adjust the theme, which is basically for the look, right? I'll go through these individually quickly, and then I'll show you some examples in R. So the data require what's considered tidy format, or you've probably seen it as long format, right? So you have to have one observation per row. If you're using SPSS, you're probably more used to something like what you have on the left right here, where within the variable name, you have some kind of encoding of a time point, maybe pre and post intervention or something like that, right? ggplot really needs the intervention or the time point to be its own column and then have a pre and a post. So you can split this pretty easily, and you can also rearrange it in the other direction pretty easily within R. But you can see on the left-hand side, you've got an ID, right? Then you've got systolic blood pressure before the intervention, systolic blood pressure after the intervention, right? And I've rearranged that then to where you have 2 rows for each participant, and now you've got a row per time point and a systolic blood pressure lining up with that time point, right? And this is how we need it for ggplot. All right. So once we have the data, we then map the data so that it's understood by ggplot. And we have 2 things that we can map. We can map what's called aesthetics. So that is basically mapping variables in the data set to the graphical properties in the geometry or in the plot, right? And this will make a lot more sense once I show you. And you can also map facets. This is a separate point later on, but this is having individual panels in the plot that show, individual, group data, for example. You can do that by participant or by sex, gender, by, whatever category you want it. You then have statistics, and these basically transform your raw data to displayed values. So, counts, distribution, summary statistics, means, medians, standard deviations, all that kind of stuff. And each geometry that's built into ggplot already has default statistics. So a lot of times you don't, if you've looked at the document I've shared, I don't ever really specify any statistics because the geometries already have statistics built in that match the type of plot you want to create. You can still change them, but ggplot is pretty good about figuring out, hey, this is the plot we want, so these are the statistics we need to run. And so the nice thing here is we don't have to compute these statistics manually. We can have our raw data set, right? And we want a bar graph or a box plot, and we don't have to go in and create a separate table that now has our mean, our 25th percentile, our quartiles, our medians, our minimum, maximum value, our standard deviation, standard errors, all of that stuff that we might need to compute separately in Excel, for example, right? R does it by just telling it, hey, we want a box plot. It runs all these statistics in the background and then plots them based on the raw data rather than having to compute these summary statistics ourselves. Then we have the scales. We can translate back and forth between variable and property ranges. So, right, we can say we want the categories shown as a color or numbers shown as a position, right? And these then always imply a specific interpretation of values. So that could be discrete variables, categorical variables, continuous variables, those kinds of things, right? And then by showing R what data type it's working with, it will then adjust the color, right? If it gets a continuous variable and we tell it to use color to show that, it will have that gradient, that color gradient, right? That we looked at before, the sequential thing with color brewer. Or if we feed in a categorical, then it knows, oh, we're going to have one color per category, right? Those kinds of, so it's pretty nice. We don't have to go in and specify that ourselves, but we can always do all this stuff manually after the fact. The geometries really is what show our plot type. And so a lot of times that's the main thing we need is data and mapping through the aesthetics and then a plot type, a geometry. And then everything else is making the graph more legible and make it look nicer, right? Then we can do the facets. I told you that. You can splitting the data into multiple panels, so by participant, by group, all that different thing. And they automatically have the same logic and the same properties, right? So that's the nice thing. If you have one panel per group, it automatically has the axes the same, right? So then it's easy for comparison. But you can also tell it, free up the axes and show it on individual axes per panel. So I'll show you some of that stuff too. And then coordinates, right? So we can change the coordinate system. A lot of times it's an XY if we're looking at the types of plots I'm showing here. But that could also be a spatial setup where we're using maps, right? Or that kind of thing. And we can adjust these coordinates. We can make the x-axis and the y-axis longer or shorter or change whatever we want to do with it. And then lastly, we can adjust the theme. So this one is not linked to the data. It does not have any impact of what we're showing with it. It just changes the look of the data. And I'll show you some of that too. You can do some pretty cool stuff with that. Okay, any questions before I move into R? Okay, awesome. So I don't want to overload this. So I don't know if I'm going to go through all the graphs I have in this presentation, but I'm going to start showing some. And then if y'all have any questions or anything you want to see how it's done, then just pop in, let me know, and I will try to show you that. Let me pull up my R and share that screen with y'all. And then I'll start showing you how to make some of these graphs, right? It's loading right now. Okay. So I had shared in my very first email also a quick overview of what R looks like. But if you haven't had a chance to look at that, just to show you really quickly, what we have right here, up here in my left-hand side, is what's considered a script. So this is where I write my code. I can save this, I can change this, I can share this, right? And this is where I give R the commands of what to do, right? My plots will pop up in the bottom right here. And what you'll notice immediately is that the plot is constrained by the size of this window. If I change the window size by pulling this up or over, right, the plot size will change. Now, this is not what the plot is going to look like once you save it. When you save it, you can change all of that. This is just kind of a preview of the plot, right? So sometimes these plots will look pretty horrible when they pop up in this little window, and you just got to adjust the size and then change it as you can always click on the zoom button to kind of get a better idea of what the plot actually looks like. The first thing we need to do is load some packages. So R has different ways of functioning. It comes with a base R installation, and then you can load all these additional packages that allow you to do different things. ggplot is one of these packages that allow you to graph plots, and ggplot is part of what's considered this tidyverse. Okay, tidyverse has a bunch of different packages in it, but ggplot is one of them. I'm also loading this medical data package and patchwork to combine plots. And then I'm also loading this GG themes to show you what all we can do with different themes. And there are a bunch of different packages out there for themes. This is just one of them as an example, right? So the medical data set package has a bunch of different medical data sets, okay? And the one I'm using is called laryngoscope, okay? So to pull that up, I just type data laryngoscope, right? And it now pulls up a data set. And if I click on this, right here in the bottom left is my environment that shows me all the objects I have. So the laryngoscope data is now an object that I can manipulate and use in R. If I click on this, it's going to pull it up just like a normal spreadsheet right here, right? And I can look through that as I want to, as I would on Excel or something, for example, right? I can also look at the data set and see what type of variables, what the structure of the data set is, by typing in str for structure, laryngoscope, right? And then it tells me over here in my console view what the different variables are. It tells me this is a data frame with 99 observations. So I've got 99 participants in here and 22 variables, right? And I have age, gender, ASA is the ASA score, BMI, everybody familiar with probably. Malampati is a score that shows us basically, does anybody know what this one is? So you actually I have one to show you, a screen to show you. Let me just pull that up. That way I can show you all of these. Where's my Zoom meeting? Right here. It's loading. Yeah, ease of intubation, right? Exactly. The structure of the palate, right? So this is looking into somebody's mouth and seeing how much of the soft palate is visual, right? Or of the palate is visual, or visible. And this will give us an idea of how easy it is to intubate somebody. The whole idea behind this data set is they wanted to compare a new instrument to see, is it easier to intubate with this new instrument compared to kind of the standard of care, right? So anyway, back to R. If I do this, it'll show us the different randomization is then which instrument was used, and that's just coded as 0 and 1, right? Attempt at intubation 1 and how long it took. Success, failure, intubation 2, and then some other ones, right? The ease of use I used for one of them, one of the graphs I did. Okay. I can also have R show me the first few values of it. See, this is what I was saying. Live coding, forgot an O right here, so it didn't work. But if I do that, right, it'll show me the first 6 values by default. I could also say tail, then it'll show me the last 6. Or I can also go in here and tell R to only show me the first 3, right? So this is just kind of looking at what we're working with. But really what we want to do is plot something, right? So what I'm going to do is, for those of you who've used R before and maybe have used kind of the base R coding way, I'm using the one that's associated with the tidyverse. So I'm going to tell R, take the data set or the object laryngoscope, and then I'm going to use this pipe operator, and I've spelled it wrong again. Let me just do this. This is a nice thing about using this RStudio right here. It will autocomplete for you. And I'm using this pipe operator. And what this basically does says, take the data, the object laryngoscope, and then do something with it. And what I wanted to do is create a ggplot, right? Create a plot. And then if you remember, the first thing we need to do is mapping the data. And that's with these aesthetic mapping. So that is the AES for aesthetic. And then I need to tell it what goes on the x-axis and what goes on the y-axis, right? So if I put on the x-axis age and I don't do anything else, it will create just a plot area, right? So down here in my plot pane, I will just get a plot area with the ages, right? So I want to put something on there. So maybe I want to look at the distribution of age, right? So what I would do then is I would do a geometry and I would do a histogram and see RStudio is already auto-completing it for me, so I don't have to worry about spelling and all that stuff, right? Hit Control Enter, and it's going to give me a histogram, right? Now it's also giving me a warning that it defaults to using 30 bins in age, and our age range, somewhere from 18 to whatever 78 or something. We could look at that pretty easily too, but I don't want to take up too much time. So it says, hey, maybe pick a better value, and it also tells you how to do that using the bin width argument. So within our GM histogram, I would go then bin width equals, and now I can say maybe 5 in 5-year increments. Now I do that, and this looks a lot more looks a lot nicer, right, than having these kind of random intervals, because that's it gave us 30 bins, so we got to look at what our age range was divided by 30, and then we would have the size of each individual interval. So that's not by year. I could do 1, and then now I have 1 bar per year. I don't know if that's the best way to show this. So 5 to me look pretty good. Okay. Now I can add some elements, right? So there is a color element that's actually, this is something you have to get used to a little bit. For most geometries, color is the border and fill is the fill of whatever object you're creating, right? So color, black, I have to put this in quotation marks, will give us black borders around this histogram, right? And so it looks a little nicer this way. Here's the nice thing when you don't know what arguments to use or how to set up a function. You can ask R. So if I do question mark geom histogram and run that, it will give me everything I need to know about what this function does, what arguments it takes. Within each argument, it tells you exactly what they do, what different values do. And then if you go all the way to the bottom, it shows you some examples. You can run these examples, and then you see, based on that code, I get such and such an output, right? You don't even have to do this question mark and ask it. You can just click on it and hit F1, and it's also going to do the same thing. This is on a PC. I don't know if that's the same on a Mac. It's going to tell you what all this function does, right? Now, I'm looking at my time, and I took a little bit longer with the introduction than I thought. So I'm going to do this, walk you through this distribution graph, or actually, let me put this out to you. I'll just ask you. This one is a histogram. I also put explanations of a scatter plot and then explanations for a uh, box plot on that document that I have shared in the chat. Is there a preference for what y'all would like to see me make? Histogram, and I will split that histogram by different groups and all that kind of stuff, put different colors on it. Box plot, same idea, or a scatter plot. Any preference of what you would prefer to see? If you want to put it in the box plot, I see a box plot here.
Box plot.
Box plot.
Box
Okay.
plot.
Yep. Cool. I will do the box plot. Okay. All right. Can everybody see my screen again?
Yep.
Okay, awesome. Now, if I want to do a box plot, I need to, you notice how here I only showed an X variable because the Y variable automatically becomes a count, right? I told you earlier, ggplot already runs the statistics in the background based on the plot type, the geometry I give you. If I want a box plot, I need to give you X and Y, right? So maybe I want to look at the ease, right? We had a variable ease. You can also click on this arrow right here and see it. So that was on a scale from 0 to 100. How easy was it to perform the intubation, right? And then we have that Mallampati score. So maybe we want to look at Mallampati score on the y-axis, on the x-axis, and ease of intubation on the y-axis. Okay, so I'm typing this out, x equals Mallampati, y equals ease. You don't have to do that. You can also leave these out, but then you need to know the order in which ggplot is expecting the arguments. Okay, if you type it with the argument name, then it doesn't really matter. But if you don't want to use it, then you need to know in which order you need to provide these arguments. And then I'm just going to go geom box plot, and I'll show you what happens. It doesn't know what to do with it, because if you look at the type of variable we have, Mallampati is a numerical value, just like all of the other variables are in this data set. So it thinks this is a continuous variable from 1 to 4 because R has no idea what Mallampati means, right? So what I can do is I can make this a factor, right? And then it knows, hey, we're using this to group by. And so now all of a sudden we've got the factor Mallampati score as 1, 2, 3, and 4. So this is the grade on the x-axis. And then we've got the ease of intubation with the medians and all the stuff you get from a box plot, right? Our quartiles and our whiskers right here. We also see that there are some NAs. So some of these participants did not get a Mallampati score, right? So we might not show these. So what we can do is we can tell ggplot to filter those out. And I'm using a command where I'm using the isNA function. So now it looks for all of the rows where there is not a data point. If you don't have a data point in a row, R will assign it an NA, right? If I pull the data up right here, you'll see some here. See this NA right here? So the function isNA searches for all the NAs in the Mallampati column. And then if you're familiar with programming at all, if you do a exclamation point, that means not isNA, right? So now I'm telling R to filter the data set to filter out all the ones that have an NA. I run the same one again, and so now it doesn't use the ones that have an NA for Malpati score, right? Okay. Now, I'm going to show you a few things of how you can include titles and all that kind of stuff, right? Because this is obviously not a plot that we would use for publication. So you can do labs, that stands for labels, right? And you just tell R what the title should be. So ease of tracheal intubation by Malpati score, right? Then maybe I want to tell it something nicer than factor Malpati on the X and something nicer than ease on the Y, right? So Y maybe ease of intubation, and I'll put that's on a scale from 0 to 100, right? And then on the x-axis, I'll put Malpati score, and I could put here 0 to 4 or 1 to 4 or whatever, or I can just leave it if we assume people are familiar with what that is. Okay, so now this looks much nicer, right? Then I could go, and I've told you about the themes, right? So I could do theme classic. And now that looks a little bit more like what you might be used to from a graph in a publication, right? Where we don't have that gray background. We've got the grid removed, the grid lines removed, all of that. Within that, we can change the size of the font. And if I use what's called base size, then it applies to everything, right? So I can make that larger, right? So now if I zoom into it, see, I told you how in the pane right now, in my plot pane, because the pane's not large enough to show that anymore, it cuts off my title. But if I zoom into it or if I save it later on, that'll work. It'll not have the title cut off. We can move that title to the center and all that kind of stuff. It's in that document, but I'm not going to show that for a matter of time right now. What I'd rather want to show you is adding individual data points, right? So that's another geometry. So if I add a geometry jitter, it will add individual data points that are jittered horizontally so that they're not on top of each other if they have the same data point, right? And so now all of a sudden I have a pretty nice, oops, it just paused my screen share. Sorry, bring that back up. Can everybody see it again?
Yes.
Okay, awesome, thank you. So now you have the individual data points, they're not overlapping, right? So we've got a pretty nice looking plot right here. I'll show you this really quickly. You could go then and use the ggsave function, give it a file name, right? So boxplot, then tell it whatever the format is, and you need to put this in quotation marks. Then you can tell it what you want the height to be, right? The width, and then what the unit of that is. That could be like pixels, centimeters, inches, whatever. You can tell it the resolution and DPI, all that stuff. So if you are trying to make a plot for a publication and you have these exact requirements, you can tell R to save it in that, right? You could do a JPEG, a TIFF, a GIF, whatever, right? And it'll save it in that, right?
Andy, I have a question.
Yes.
So does it only save in sort of like image formats, or could it be exported into something that you could further modify it if you wanted to?
That's a very good question. Yes, I believe you can modify it into stuff that you can further modify as well.
Okay.
But I'm not, I need to check on that.
And I had another
Um,
question, because
yep,
it's not like some of the data I work with, and this goes back to one of your key comments at the beginning, the importance of understanding if you've got to include the zero or
right.
if you cut the data. So, we work in like, let's say timing, like millisecond timing of like EEG activation. Like people are not going to have responses for the first like 200 milliseconds. So
Yep,
we tend to cut data, right? So we tend to cut the
yep,
scale because it's empty. Like there's not going to be anything. And so if
yep,
we want to properly scatter plot relationships between, the timing of like an evoked response related to like depression or anxiety, like we do need to cut that. So like, how would
yes.
you change your scale here?
Um, so you can, some different things. So what you can do is, for example, here I could do a scale Y and it's continuous data on the Y, right? So you need to know what type of data I have. And then I can give it limits and I can give it, so I could do limits, right? And then I could start it at 25 and cut it off at 75 or something like that. This is not ideal. You can, because it now will just not, could not function, find function limits. No, this should be an equals, not a function, sorry. Um, See, now it starts at a 25 and it ends at a 75, but it gives you the warning
Mm-hmm.
that it removed all the data files, data the data that were outside of that range, right? You can also change that with a chord Cartesian. I've not used that in a while, so I'm gonna have to look. So xlim, that's a slightly different. So the x limit would be. I'm gonna have to look at this. This I've not used this one in a minute.
Because we often will look at it and say, okay, what is our
Right.
like what is our range and make sure we capture all of that. But I didn't know if there
Yep.
was like a smart way to do this, say, hey, look at the Y distribution and like
Right.
basically take out stuff that doesn't
Yep. And
exist.
so the filter argument right here is something that you could also do. So you could tell it to only include, if I take this all the way out, you could tell it we want only the ones that have ease scores of over 50, right?
Okay.
Um, and so now you can already see it doesn't even have the zero included in this one anymore because everything is above 50. Right? So
Okay.
if you had something on the X or the Y axis, then you could just put in a logical argument where it looks, is the value above or below or equal to something, or you could even create a list and say, is it contained within that list or something like that, and it
Okay.
will only use the values that are in there.
That's helpful. Thank you.
Yep. Um, I will show you just really quickly, and I want to leave just a few minutes for quite additional questions if we want to. But if we wanted to like increase an additional thing, sorry, include an additional factor here, we could see, hey, the study was done to compare two different instruments, right? So what we can do is add this fill argument and say we're now also comparing instruments. And the way they've got instrument coded in the data set is randomization, right? Um, and then I run this right here. And so now it also splits the data by instrument right here, right? You can then go in and call this label um sorry, this legend title, make that look nicer, put the names of the instruments right here rather than 0 and 1, all that kind of stuff, right? But you can see how all of a sudden it's pretty, now with one command, we've got it split by instrument on top of by the Malampati score, right? Um, what we then could do, we can see, hey, Malampati score 4 didn't have both instruments used. So then in our filter, we can say we want the Malampati score not to be 4 or less than 4, right? And so now all of a sudden, something didn't work right. Oh, it's because I got my parentheses in the wrong spot. Right here. So now we're only showing the 3 anymore. Now the jitter isn't maybe the best thing right here because now we don't see which data points are with which instrument. So instead of a jitter, we could do a geom point. And then within the geom point, there's a nice little function that's called, or argument that's called position. And the position here would be position jitter dodge. And now it actually arranges the individual data points by um, by instrument as well, right? So now all the ones that were done with instrument 1 are lined up with this box plot. All the ones that were done with instrument 0 are lined up with this box plot, right? So I hope that gives you kind of an idea of how versatile this is and how quickly you can change your graphs just basically working with a few commands and the raw data. And you can make these interactive, you can make them animated. You can create dashboards that create live graphs if it's not for publication, but it's for some kind of presentation, or you want it on your website or something like that. It's insane the stuff you can do with this. But I've taken quite a bit of time. If you want to look at um, that document I shared, it has some things on combining graphs into different panels with then calling them A, B, and C. There's really unlimited options with the software. And I think I'm going to stop here for now and just let y'all ask any questions if you have anything.